Hello guys, this is Chandana C from BSc I hope your day is going good. Today in this video we are going to look functions of memory management. There are actually 6 kinds of functions of memory management, that is basic hardware, dynamic loading, address binding, dynamic linking, logical and physical address space, and overlays. As this is a group seminar which we can't take on YouTube, so we divided this seminar into 2 parts. This is part B, and if you want rest 3 functions which I'm not covering here, which is part A, I'm giving that link in the description. You can go check that. So in this video we are just going to cover dynamic linking, logical and physical address space, and overlays. So before knowing that, we should know what is memory management, right? So managing the memory. So how we are managing the memory is called memory management. What will this memory management will actually do? It will keep track of which part of the memory is in use and which part of the memory is not in use, and it will allocate the memory if it is necessary for a particular program, and if the memory is if the process is over and no need of that memory, again it will deallocate it. It means it will take back the memory space provided for it. So this is what the management memory is doing. Like it will manage all these things, and yeah, the rest 3 are basic hardware, dynamic loading, and address binding, which you can see in my friend's video. Moving to our topic, dynamic linking and shared library. If you're watching this video, you must be a CS student, right? Then you will be then you should have come across C programming, where we use shared libraries like studio.h. Remember? Yeah, shared library is nothing but the same. Here also we are using some libraries, like for example, I can use math library, math library, for addition, subtraction. I need not to code for everything, like addition separately and multiplication separately. If I install math library, that is sufficient. And this is what dynamic linking and shared library says. So in Unix we are calling that as dynamic linking. We are not much calling it as a dynamic I'm so sorry. We are not considering it as a shared library, but we are familiar with the word dynamic linking, and DLL is in the sense dynamic linking libraries, and this makes our work easier. Like it is easy to update and upgrade the things. Like if I want to upgrade, I need not to update in separately, like addition separately, multiplication. If I update the math library, that is enough, right? So this makes our work easy. And moving on to the advantages. Updation of dynamic linked libraries is at one place. As I said, library is in one place, right? So updation of one single library is enough for that entire programs which are built in that particular library. And all processes using a language library executes only one copy of the library code. For example, if I'm having a language library, this language library I'm using in different processes. It need not to be having different memory spaces for each language library, right? Only one language library stored in a particular memory is sufficient for accessing in all the processes. So it will minimize the memory, right? Memory space allocated. And dynamic linking requires the operating system's help. See, operating system here will help the dynamic linking to check if whether the storage of the language library is repeated or it is stored in 2 or more memory spaces. So operating system will help us in that matter. Moving on to logical and physical address spaces. Normally an address generated by the CPU is called as logical address, and whereas the address generated by the memory unit is called as physical address. And logical address is also known as virtual address. Address is bound to become if you are doing a particular program and you are saving that file during the time of compilation, then logical address and physical address will be the same, right? Because during the time of execution, coding itself, we will sometimes save the file, so it will store in a particular space, and after completing the program and executing, and the whole thing will be stored in some other place, so it will differ. But actually when we do it in the time of compilation, both will be the same. And when you do it at the time of execution, that is, one is already saved while before running itself. First we will save the file and then we will execute Unix operations, right? So that kind of thing. And after execution it is again stored, so that maybe it will be stored in some other places, so it is not identical. Oh, I'm so sorry. One second. The runtime mapping from a logical address to physical address is done by the hardware device called memory management unit. I hope you understand, need not much explanation about this. It is very easy. The set of all logical addresses generated by a program is known as logical address space. Similarly, the set of all physical addresses generated by the memory unit is known as physical address space. The base register is called as relocation register. For every address generated by a user process, the value in the base or relocation register is added and sent to memory. So overlays is very easy. It is used to manage the memory. For example, what you do when your phone run out of the space, like you don't have any more GB to use, but you should store a particular file or a video which is some 2 GBs. So you don't have space, right? So what will you do? You will delete the old videos or photos or some files, or which is not at all necessary. That kind of things you will put into trash, right? So the same thing is called as overlays. So here, whenever we need a particular information or instructions to be loaded, only that comes to our memory, which is already there will be some set of instructions which is already there, right? So that will be removed, which is not necessary. If that is not necessary, that will be removed and the new one will be placed in the same place, so that memory will be managed, right? Need not of new memories each time. We can remove the old one and we can input the new one. Advantages: it requires only small amount of memory for working. It is true, right? Because it is not using much space and it is only deleting the older files and it is installing in the same place, and it does not require any special support from the operating system, and it can be completely implemented by the user using a simple file structure. It can be easily built. Disadvantages: using this overlaying is used in microcomputers also, but then the problem is that won't support to the high technology, right? Yeah, it will have a little bit space. I mean, it will have only a less memory space. That's what the reason we are using overlays. But then sometimes it will not support the advanced techniques which we are using in this. And programming design of overlay is complex. To design a program of overlaying is quite difficult. And that's all for today's video. Thank you for your patience and time. Have a great day. Thank you.